Okay, let's start with the conditional statements. So the conditional statements, if clauses in Python, has a huge use cases, and it creates some conditions that if the conditions met, you can use that option, that code block. Otherwise, you can use the other code block. So it's all condition based. So why we use conditions? Because some specific patterns, some viral loads, some DNA or RNA, some ambiguous nucleotides, some variants that we can apply some rules to filter, classify, or react to the input. So the basics if statement looks like this. So let's say we have a sequence in here. So if you say if something, if x, I, whatever you want, in your variable, which is here, print start codon found in the viral sequence. So this is one condition. So there are many possibilities rather than this one. So this is the first one, but some of the others are missing now. So we will come back to that. So let's see the second example, DNA sequence input. Let's have a sequence from the user. We know that what it means. So if ATG in the DNA sequence, print start codon found, but else print no start codon present. So now we have two conditions. So the first one is this, which case is start codon found. The second one is no start codon present. But sometimes we don't have, like, there's no black and white, so you can have more conditions than two. So let's check that option. So in the next example, let's see what we have. So we have nucleotide input from the enter a nucleotide from the user, and one condition is here. So if the nucleotide equals to A, adenine detected, elif. So else if, actually the abbreviation of else if. So this is the first condition, this is the second, this is the third, this is the fourth. Any case rather than the first four will be this condition. So anything else gonna be invalid. So you don't need to go one by one for each condition. You can define some of the conditions, but you need to be careful. Then you can define else as anything else rather than the conditions that I defined previously. So let's run this code. We can run this code, ATCG. Let's write everything. So what do we have? Invalid, because I have every other things. And let's put something valid, ATCG. Again, it says invalid. It's wrong. ATAGCTG. Oh, that's interesting. A. Oh, and then undetected. Oops. T. Okay. Now it's working. Why? You know why? Because we are defining a specific nucleotide. So it should be equal to adenine, not a sequence Like you should give a nucleotide, as we say in here. So what if we are missing some of the important conditions? So it will come out when you test your code, like when you test the edge cases with your code, and you will see some of the edge cases and some of the problems that you can have in your code block. So it can be uppercase, it can be lowercase, it can be invalid characters like some of the letters that are not in English, and it can be messy sometimes. So let's check this example in here. So what it says nucleotide have an input from the user. Check if user entered the sequence instead of a single nucleotide. Okay, so we have another condition that we didn't mention. We haven't mentioned in the previous one. So let's put A. It says adenine detected, and if I shift enter again and put glutekin, you entered a sequence rather than a nucleotide because I entered a sequence, but it's not enough because this is not a sequence. So you have to add another elif here if nucleotide can we say higher than 1, let's say length of the nucleotide is higher than 1, you can check you can say print oh, we have the same here. Sorry, okay. So you can add another options down here as you grow your code block. So let's go to the next one. Another example, sequence input. So we are having a sequence. If something in the sequence, print echo restriction site detected. That's an example. That's the echo site. So anything else, no echo restriction found. So we can, you can multiply your examples like this. So if something in that, you can print. If something in that, you can say check the length of the sequence, and you can download that. So in the summary, if statements execute a block of code when conditions are true. If else, there are two paths like black and white. If else statement handle multiple branching conditions like black, white, gray, yellow, green, whatever you have, whatever color you have, like there are multiple options, and you have to mention and define each conditions clearly, otherwise you can end in trouble. So you can validate your sequences, because sometimes sequences has something rather than A, T, C, and G. You can detect codons and restriction sites. You can classify the GC content. If GC content higher than, like if it's 40% and you're looking for something that 40%, you can print a warning sign. You can differentiate between DNA and RNA, but mostly we're dealing with DNA. You can flag samples with high viral load from the metadata. You can make decisions dynamically in automated pipelines. You can say that if the number of reads higher lower than 100,000, just exclude that sample. It's that easy. So you can exclude that sample from the downstream analysis. So we're going to the next one.